5.2, the first part was factoring. So to continue with 5.2 is solving. Solving our quadratics. Hopefully remembering from the first part of 5.2, a quadratic means that there is the highest power of 2. Quadratic, we have the highest power of 2. So like an x squared, that's what we're getting at. So with yesterday's assignment, or the last couple days' assignments, we had ax squared plus bx plus c, or a minus in there. Well, what's going to change with today's is when we're solving is that now we have an equal 0. That's going to be the difference of today, is that now we have an equal 0. Whenever you have an equal sign, you're solving. If you don't have an equal sign, you're simplifying. And that's what factoring is. Factoring is a simplification process. So whenever you see an equal sign, you solve. If you don't see an equal sign, you don't solve. So in order to solve, every equation, the very first thing is every equation must equal 0. If it doesn't equal 0, you can't solve it. It has to equal 0. Then we're going to factor, and we're going to factor all of the methods that we've been working on. So binomial, trinomial, with a leading coefficient, no leading coefficient, GCFs, all of that. Then we're going to set each factor equal to 0, and we're going to solve for the variable given. All right, so that's the actual process and the actual steps. What I'm going to do is we're going to pull out I'm going to pull from the last notes examples. So on the very first one that we did on 5.2, we said 3x squared minus 9x, and if you wanted to just copy it or flip back quick to it. Today we're just going to throw an equal 0 on the end of it. So the factoring part of it, again, which should be a review topic from Algebra 1, and you've been practicing it for the last couple of days, so factoring it should not be an issue at this point. It's now looking at solving. And once you have factored, that's what we have here, step 1, step 2, we set each factor equal to 0. So 3x is 0, x minus 3 is 0, and we solve for the variable. So we get x is 0 and 3. That's our solving method. Now, that actual step here of writing each one, you probably won't have to do after these examples. Most people are going to pick up real quick on how to be able to solve these. If not, you're still welcome to write them out, but it will not be a requirement. All right, let's go to another example from that first day. 25x squared minus 81. We factored this down to 5x minus 9 and 5x plus 9. Again, I'm going through this fairly quickly because we should have already done this. But today we're throwing on that equal 0, because in order to solve it, it has to equal 0. No equal sign, no solving. If I were to set each factor equal to 0 and solve for each variable, first one I would add 9 and divide by 5. And the second one I would subtract 9 and divide by 5. So I would get a positive and a negative 9/5. Now, you can write that as a positive negative 9/5. You can separate them. That's absolutely okay. Or you can combine it. That is fine. Just make sure you have both plus and minus there to signify that both solutions are possible. Okay. Let's go to x squared plus 2x plus 1. When we factored this the other day, we got x plus 1 and x plus 1. And then we wrote this as x plus 1 squared. Now that is true when you're factoring. You would write this as x plus 1 squared. But when we're solving, we got x is -1, -1. Well, just like when we're factoring, we don't write the quantities twice. Well, we don't write solutions twice either. What we would say is that this is actually -1 dr, where dr stands for double root. This tells me, dr tells me it happened twice. It tells me it came from two factors that were the same. So when you have two factors that are the same, you would get two solutions, but we don't write a solution twice. In math, we use the shorthand dr. dr stands for double root, and that says that there were two -1s. Okay. X squared minus 5x minus 24. When we factored this the other day, we got x minus 8 and x plus 3. At this point, hopefully you're picking up that you don't have to set each factor equal to 0. You can just go, oh, this one is 8, this one is -3. If you're unsure, feel free. X minus 8 is 0, add the 8 over. X plus 3 is 0, subtract the 3 over, and you get that same solution. But you do not need to write anymore that separation of factors. You should be fairly confident with it by now. Okay. 2x squared minus x minus 3. Throw on an equals 0. When we did our bottoms up method and we factored this, we got it all the way down to x plus 1 and 2x minus 3. If you're unsure how that came about, go back to your notes from a couple days ago and look at the bottoms up factoring of this. So that this solution is a -1 and this one's a positive 3/2. Next one, 5x squared plus 20x minus 25 is 0. When we factored this, we had a GCF of 5, a factor of x plus 5, and a factor of x minus 1. Now with the two parentheses, we really don't have too many problems. This one's going to give me a solution of 1. This one's going to give me a solution of -5. When I have a GCF that has no letter, if I were to set each piece equal to 0, I get 5 as 0. 5 can never be 0. So this does not give me a solution. Only the ones with letters give me solutions. -5 and 1. Now let's go back to this very first one that we solved, and we had a GCF. This GCF has a letter. A letter gives me a solution. GCF, no letter, no solution. Understand those two differences. If there's a letter, there's a solution. If there's no letter, there is no solution. So solving generally is pretty simple for us because the factoring part is the actual work part, and that's the where we have the most difficulties, but we should be able to factor fairly confident by now. Therefore, we should hopefully be able to come up with the solutions, and we'll be practicing some more of them in class.